Hello students, welcome back. This part is about the one-way ANOVA procedure. What are all the various steps we will follow in one-way ANOVA procedure? There are various steps involved in performing one-way ANOVA. So, the very first step is description of the data. We will describe whatever data we have collected based upon our research problem. Then we will validate the assumption. Thirdly, we will set the level of significance, and we then state the null and alternative hypothesis for the problem. We calculate test statistic, and then we will try to find what is the sampling distribution of the test statistic. Based on that, we will calculate critical value. So, based on comparing the test statistic value and the critical value, we make the statistical decision. But due to the use of computers and packages, we are getting a p-value that we will discuss in the next succeeding videos, and then how to write conclusions and write the report of the results. When we start our ANOVA procedure, we first start with the description of data. So, how we can describe the data first? We are going to narrate what is our outcome variable or the response variable, whatever we have measured from the subjects. Now, we will decide what is the number of groups we have, or the number of interventions we have compared, or what is the number of levels in the factors. Let us represent them by k, and we have the number of observations to be measured in each of the group, that is n1, n2, n3 up to nk. So, what is the size of each group we are going to define, and then we will try to calculate. So, basically this will come in the designing of the stage. So, with some objective in mind, for comparing more than k groups, we would have collected the sample size, but in some cases we would have calculated an equal number of observations or equal size in each of the k group, but due to practical difficulty, some subjects would have not followed up in our study. So, we may have unequal observation in each of the group, but that is not a problem in performing the one-way ANOVA. So, after describing what is our outcome variable number of group, we will move to see what are the observations we have for each of the groups. So, here I have an example. Say there is a group A and group B and group C. So, in group A we have 5 observations, and in group B we have again 5 observation, and group C we have 5 observation. So, there is no loss to follow up. So, we have a complete set of information what we have proposed in our study. So, it is important to know when we are trying to do a research on any research problem, we should know how to represent that in a data layout format, which is which can be easily acceptable by the statistical packages. So, we are going to deal with only 2 variables, dependent variable and independent variable. Now, the dependent variable is the anxiety score, for example. So, the 3 different groups are the second variable. So, though I have coded it as SA, MA and AV. So, those are the 3 groups. So, in order to perform an analysis of variance in any statistical packages, this is a basic data layout a researcher has to make to perform a one-way ANOVA. So, those things we will discuss in the subsequent lessons. Now, after we described our data, we will move to validation of the assumption. So, in the previous lesson, I have discussed what are the validation technique for our assumptions. So, recollect that we have 2 important assumptions, that is our data is following normal distribution within each group, and the observations are independently measured, and then we have to check for any outliers in the data. Outliers are extremely lying observation from the rest of the observation, and then we have to verify whether the variances for all the groups are equal. So, these are the important assumptions. These must be validated before you choose to perform one-way ANOVA. So, I repeat. So, the normality of the data can be assessed using Kolmogorov-Smirnov test as well as the graphical procedure such as histogram, and then we can look for outliers by using a box plot, and the equality of variance we may assess using F test for equality of variance. After validating all these assumptions, we shall go for the actual ANOVA procedure. So, next we will fix what is the level of significance. So, recall that the level of significance is nothing but the minimum value of alpha error to be fixed by the researcher before performing the study. Usually it is fixed at 5%, that is our alpha level is 0.05. Next, after finishing the setting up of level of significance, we will move to stating our hypothesis for one-way ANOVA. So, the null hypothesis to be stated is, we are going to compare K population means. So, we start with there is no difference between the means of K population. So, this is our null hypothesis against our alternative hypothesis is, so this can be expressed in many ways. You can say there is a difference between the mean of K population, or you can say at least a pair of means are different. So, we are saying that the K population means are not equal. It means there could be a pair of means are different, or all of the means are different, at least a pair of means different, we say there is a different. So, this is our alternative hypothesis. So, notationally we can express our null hypothesis as mu1 is equal to mu2 is equal to mu3, so on up to mu k, and null hypothesis, the alternative hypothesis is expressed as mu I not equal to mu j, where I should not be equal to j. After framing our hypothesis, next we move to calculate the test statistic. To calculate the test statistic, we must calculate the estimate of within group variance. So, which is calculated based on the within sum of squares, that is SSW, that we have already mentioned in the previous slide. When we divide the within sum of squares by within degrees of freedom, we will get the estimate of within group variance. Usually this is called mean sum of squares for error, but in our lesson I am representing this by estimate of within variance represented by small s w square. So, the next estimate to calculate the test statistic is estimate of between group variance, that is SB square, which is again calculated by dividing the between group variance divided by degrees of freedom for between group. So, this is otherwise called as mean sum of squares for treatment. Now, we are moving to the actual calculation of test statistic. So, before moving to the actual calculation, we will just see how the values of this mean sum of squares for error and means between sum of squares. So, basically when you have the estimate of between group variance is more than the estimate of within group variance, then it is more likely to reject our null hypothesis. Otherwise, you do not reject the null hypothesis. But how large to reject the null hypothesis? How large is your between sum of squares from the within sum of squares? So, everyone will come to a subjective conclusion. So, to have an objective conclusion, so R.A. Fisher have given this F ratio, which is the ratio of these two estimates within mean sum of squares, within mean sum of squares and between mean sum of squares. So, this is named in the honor of Professor R.A. Fisher, that is why we are having the letter F. Next, if this H naught is true, then SW square, that is within sum of squares of estimate and between mean sum of squares will be approximately equal. So, if it is not so, our F ratio will exceed 1. So, we have a greater chance to say that we are going to reject our null hypothesis. So, we can conclude the greater effect is there for the treatment. So, the greater the treatment effect. So far we have discussed about how to compute mean sum of square for error and mean sum of square for treatment. Based on that, we have computed how to find F statistic. We will continue in the next video. Thank you.